Some of the hardest problems in the world exist far above the planet. Our job? To launch the smartest solutions, to protect our satellites, clean up our clutter, to propel breakthroughs in propulsion, to learn more about our place in the universe, to outpace emerging threats. Every day, the Aerospace Corporation uses the latest technologies to ensure our nation's safety and leadership in space.
Hello, and welcome to the Space Policy Show. We have a great episode for you today. Before we get into that, though, you can find us on Twitter using hashtag the Space Policy Show, or engage with our experts on Vimeo using the chat box. We would also love it if you would sign up for our news alerts at aerospace.org/policy. Today's episode is on what's now and what's next in space cyber with Brandon Bailey and Lori Gordon. In today's episode, we're joined by aerospace experts Brandon Bailey and Lori Gordon as they discuss some of the key policy and technology issues of cybersecurity in space and findings from Brandon's research, including his most recent paper, Establishing Space Cybersecurity Policy, Standards, and Risk Management Practices. His other work includes Defending Spacecraft in the Cyber Domain and a great video on DEF CON 2020, Exploiting Spacecraft. Brandon Bailey is a senior project engineer within the cybersecurity subdivision at the Aerospace Corporation. He has more than 14 years of experience supporting intelligence and civil space customers, including NASA. Our host, Lori Gordon, is a complex systems strategist at the Aerospace Corporation, specializing in infrastructure security and resilience at the intersection of technology and policy. Over to you, Lori, to get us started with this interesting conversation.
Thank you, Rebecca. Brandon, it's great to be with you today. So always great to tag team with you on some fun cyber projects, and really appreciate your being able to translate technology into policy. So that's great. So can't wait to kick it off today. So just to kick us off, what are some of the key cybersecurity areas of focus that you're working on with some of your government sponsors?
Thanks, glad to be here. So some of the things that I'm working on is trying to focus a couple different initiatives at Aerospace currently. So like the old saying goes, you can't boil the ocean, so you need to focus on a few distinct problems as much as possible. So what I've kind of been doing is trying to break down the problem into two areas that obviously make sense for space systems. So that'd be ground system cybersecurity and space system cybersecurity. On the ground system side, there's been a lot of focus recently on software assurance. As we all know, that's an important piece of the cybersecurity posture of our systems. I mean, with the SolarWinds attack and things like that, there are the software supply chain is very big issue. There's also an area of kind of renewed focus for a lot of people as it relates to ground systems, which is the industrial control system components. So I've been working in that area, trying to shore up the cybersecurity of the industrial control components that support our ground systems, as well as trying to help projects and programs translate high-level guidance into requirements, because that's a big sticking point. Is there's a lot of security that's described in high-level policy guidance and documents, but getting that translated down to implementable requirements is a little bit of a struggle. It appears. So I've been focused on that, and then occasionally I get to dive into the technical side on the ground systems and do some penetration testing and things like that, so that we can assure that our systems are secure on the ground. For the space side, I have been trying to focus similarly on that in regards of requirements. So we don't have a really solid set of cybersecurity principles and requirements that are kind of adopted and accepted across the community for space systems, specifically on the vehicle. So I've been trying to figure out a way and approach that we can really shore up the space vehicle moving forward and getting onboard security implemented. And then the last thing is, as a focus area, has been focusing on using simulation and simulators, high fidelity simulation, to do cybersecurity research for the space vehicle. So that's kind of the things I've been working on in the past year or so while at Aerospace. So it's been a lot of fun, and can't wait to keep pushing along.
That's great. We'll get to some of your work on cybersecurity standards in a bit, some of your defense in depth work as well. But just wanted to get an understanding for the audience about, from your perspective, what are the bigger cyber threats that you're seeing across national security space civil space and commercial industry, and how do those different? How are they different? Um, do they need different types of controls? What are your thoughts?
Yeah, from a threat perspective, there is a little bit of a overlap, regardless if you're in the national security space, civil space, or commercial space area. And so when you talk controls, you're talking, security implementation, which ties a lot to policy. So if you're talking about those three individual sectors, kind of can start the conversation there as it relates to policy and high level security requirements. So they are varying levels of high level security requirements and policy for space. So it's not as uniform as you would expect. Whereas the even though you're all operating in space, which is a common area, the overarching guiding principles and policies are a little bit different from what you see there. So that in line brings in a little bit different security. But from a threat perspective, it's pretty similar. The difference is maybe the motivation to go after an asset. So whenever I do kind of a cyber threat analysis or cyber threat assessment of a space system, you kind of do your kind of traditional analysis of impact. So impact to a science mission, impact to a national security mission, or impact to a research mission. Those impacts are a little bit different, and so an adversary may not necessarily want to go after a research mission or anything like that, but they may want to go after some sort of national security mission. So what we like to do is think of the cyber threat in like a tiered model from an adversary perspective, like how from tier 1 to tier 5 maybe on level of capability. So if you think about cyber threat actors and cyber threat in general, the likelihood calculation in the impact likelihood scale is kind of what I do as a three-legged stool approach. Is one is stool is capability, one is difficulty to exploit a particular vulnerability, and one's the motivation. So the motivation does vary, difficulty does vary occasionally, but the adversary capability, that's rather applicable across all the different threat tiers. So that's kind of where I see that as it's a sliding scale, and it's all within the motivation of an adversary to kind of go after, because their capabilities are pretty synonymous, and they could go after a civil space science mission just like they could go to a national security mission. But given those capabilities are pretty advanced, they may not want to burn and let people know that they know how to do certain things. So they want to reserve those capabilities to have the highest impact, like during a conflict, for instance. So that's kind of the way I feel about the cyber threat perspective currently going on.
So pulling out the thread a bit, in terms of adversary motivation, it seemed that sort of, I guess, the crown jewels would be to target national security space, and that might have been sort of the predominant mission or motivation from threat actors a few decades ago. But now it seems that as commercial space, is increasing in trajectory. There's more vehicles up there. How do you see that is changing, or when did that shift happen in terms of now commercial space is also targeted as well? And what relationship, if they get into the commercial side, is it easier so then that they can connect into the national security space too?
Well, so I think it's kind of two areas come to mind when you mention that. Um, one is the commercial assets are being used for national security capabilities, with satellite communications and things like that. So with the commercialization of space, and just in the astronaut side and SpaceX and things like that, we are using commercial companies to do things traditionally done by government. So that's kind of where I think that it's moved from one to the other, is these commercial companies are providing key capabilities for our nation, and so they've now become into the focus. So the nation state adversaries that will go after your national security missions now would target commercial companies, because they're performing some of those same functions for those same um, government agencies. So that's where I see that kind of playing in. And also, if, with the commercialization of space and things like that, the barrier to entry to space is a lot smaller. You can get assets into space a lot easier. Now you have, 20, 30 years ago, you only had a few select countries that had capability to actually launch an asset. and develop that capability to even get anything into space. And now it's much easier. I mean, colleges are now putting assets into space and CubeSats. So the activation energy and the level to the knowledge you need to get to space has been severely reduced. So it's just opened up kind of Pandora's box from that perspective. Is a lot more knowledge is being spread, and we kind of understand now that this is the security by obscurity model is kind of no longer relevant in that regard.
Mhm. So pulling that thread a little bit more, we can think about, you know, supply chain as being part of, the national defense sector. They're leveraging commercial industry as part of their supply chain. So you've done some work on standards development in terms of defense in depth, and I think that supply chain risk management, or maybe CSCRM, CyberSCRM, is part of that later defense. Can you talk a bit about that in more detail? Supply chain risk management, and how is that a piece of that
Yeah,
layered defense approach?
yeah. So yeah, a lot of the work that I've put out in the last year and even before is really focused on defense in depth as a measure. And I've been probably for 5 years or more, really been harping on software assurance and software supply chain, as I believe that is a fruitful vector and a much easier attack vector than some of the other vectors that may be out there. So we're kind of seeing it. Just in 2020, there's been 5 documented software supply chain attacks on world governments. The most
Mhm.
the most well known is obviously the SolarWinds sunburst malware and intrusion into that supply chain and getting that information out to or getting those access into many government systems via that vector. So I feel like software supply chain is a huge issue. There's the surface is so large, and given how we've developed software or doing software development these days, and we're bringing in commercial components to do certain jobs. We're bringing in open source components to do things. We're outsourcing a lot of information that just spider webs the attack surface, and need to secure those supply chains. So it's a very very difficult problem to solve, and I think adversaries have recognized that you can do your due diligence and still have many gaps in that area, and it's proven to be fruitful for adversaries, not just in space, but just cybersecurity in general. The software supply chain is huge, and there's a lot of different things we can do to help sure that up. And that's one of the things I'm working on, is trying to get that word out on all the different technical methods, requirements, and things
Mhm.
like that we can really push forward to better secure the supply chain on the software side. The hardware supply chain is similarly uh, important, but I feel like it's much more difficult maybe to subvert some of those supply chains in national security space from a hardware perspective. But it's still an avenue, and Aerospace is doing some great work in that area over the past 5 years, researching how to shore up the supply chain and what sort of technical approaches you would do to help flush out some of those hardware-based trojans and things like that for your ASIC and FPGA type implementation. So I would highly recommend people looking into some of the aerospace work that's been done there, because it's very it's very advanced, I think, and should be a gold standard moving forward.
So when you think about adversaries and threat actors, there's nation states, there's independent actors, there's insider threat. Can you characterize what some famous or infamous cyber attacks might be that a nation state carried out versus an individual actor versus insider threat
Yeah.
to the space
So
community, or even beyond that?
yeah. So when you kind of phrase that question, I immediately kind of go to this nomenclature, this tier based adversary kind of breakout that we've put out in several papers and presentations and things. Is it's just think of it from just a 1 to 5 scale, tier 1 to tier 5. Tier 1 being your most novice attacker, what they would call script kiddies in the cybersecurity community, just kind of anybody pulling exploitation code from open source resources like GitHub or things like that, and launching attacks, to your highest adversary tiers that have the ability to, one, build their own satellite communication infrastructure or build their own satellites to do rendezvous proximity type operations in space. So you think about that sliding scale of a 1 to 5. That's kind of what we're dealing with, and to kind of understand how that works is the ground systems. We feel like any tiered adversary can kind of operate in that paradigm. So your tier one adversary, when you're on the ground, you're trying to thwart the tier one adversary threat. If you're looking at more of supply chain intrusion type things, like hardware-based supply chain intrusion or software supply chain intrusion, that would be things that you would talk in your tier 4 and 5, your higher tier actors, or if people that or adversaries that would develop their own command and control infrastructure where they would have their own satellite dishes and capability to communicate to low Earth orbit or beyond. Those are your tier 3 to 5 type adversaries. So if you think about that sliding scale that you have to deal with, that's how you kind of do your risk calculations to understand what type of security you should probably put in, because you try to articulate, well, what do we think an adversary would go after? What level of adversary do we need to be resilient against? So national security space obviously needs to be resilient against tier 5 and below, whereas maybe research initiatives and CubeSat type things that are in space for 90 days only to do a very succinct mission, and they don't have any thruster or propellant, they maybe only need to be resilient to a tier 1 adversary type thing. So you kind of use that sliding scale as a guide. But specifically, you're talking about some kind of documented known attacks that have occurred. I mean, there's some well-published information out there that's probably more in your tier 3 to 5 area, where you had command locks occurring on science satellites within NASA, where you've had adversaries being able to lock on and achieve close to command capability from their own ground station type of thing. Then there's been intrusions into ground systems more recently, and probably 2018 was one that's kind of well documented through the NASA OIG as it related to the Jet Propulsion Lab. Actors were able to get in there and get access to mission systems on the ground side. So that was documented in their IG reports. So there's been a couple, like in the civil space arena, that you can kind of talk about in the open public. Then something that's rather interesting when you kind of relate to this is the Black Hat 2020. There was a paper from an individual that talked about how he was able to pull information on satellite downlink of commercial internet providers that weren't properly protecting their information. So the research community, is getting, that's probably more your tier 1 or tier 2 adversary. They're not usually malicious, but these are individuals who have some skills, but they don't necessarily have a need to disrupt anything, and they're just doing research. So it goes the whole spectrum, and you're seeing more and more with research published. Aerospace is putting out information, presentations at hacker conferences like DEF CON, the Hackasat event like DEF CON this year. So there's a lot of people that are kind of operating in this area now that traditionally hadn't operated. And then the last thing to say here, the one thing you mentioned outside of supply chain, it was the insider threat, which is an extremely difficult problem to deal with as it relates to just protecting an asset, protecting ground systems. Is insiders have the knowledge, access, and probably capability to really do harm. So personnel vetting is huge in that regard, as well as building in some of those more traditional defenses on the ground and even on board the vehicle to in the event you are resilient against insider attacks. So that's something that people really need to be aware of is don't just assume that if an insider were to go rogue that your mission is ended or your capability is you kind of just killed. Think about how you can be more resilient to that type of an attack. So just something to think about is don't just assume, because I've heard this in meetings and things. It's like they just assume, well, if we have an insider that goes rogue, we don't really have protection against that, and we're just going to basically throw in the towel. And I don't think that's the right approach. We need to assume the worst, assume that we would eventually have bad actors on the inside, and then how do we build defenses around that to be resilient against those attacks and detect and respond. So I know that was a long answer to the question, but was kind of a loaded question. So
Yeah. So, in terms of resiliency and redundancy, I just keep going back to, and I think we should talk about the defense in depth, the layered approach. Like, let's just say, take insider threat. What are some redundant protocols or approaches you might employ to ensure that resiliency or redundancy against that threat? Or what is,
yeah, so the
describe the
insider,
onion and how it applies?
yeah, so if you looked at any of the papers that we've put out more recently, it's been talking about like the onion diagram as you refer to it, where you have the data protected by all sorts of layers of security. But specific to insider threat, what I articulate to individuals is, well, so there's the insider threat from an operations perspective of an asset that's flying, but there's also the insider threat from a supply chain intrusion perspective too that you got to worry about. So if we're to narrow it down, because we talked a little bit about supply chain, narrow it down to maybe like mission operations of assets that are currently flying. How do you prevent an adversary to try or prevent an insider from you doing something harmful to a vehicle? So some of the things you would do is on critical command, critical capabilities, critical functions of a particular mission or asset. You build in protections, two-man rule type protections on certain types of commands. You have, you need to in order to command the vehicle to do some sort of thruster burn, maybe you have to have a two-man review of the procedure and the commands that go up. So you have a little bit of redundancy from not one person can cause you harm. You need kind of collusion between multiple actors. But to protect it on the insider side is there's been a lot of research in previous years within aerospace and others is building some monitoring and defense capabilities on the ground system side, so that if your ground system was to be leveraged against you from a threat actor or an insider, you have the ability to detect and respond to those attacks within the ground system specifically. And we'd like to see that extended on board the vehicle in the future as well as part of the defense in depth approach. Is that way, if your defenses on the ground fail, if you have a person that goes rogue and you don't have any ability to stop them from communicating to the vehicle, hopefully you build in protections on board the vehicle to understand that this isn't necessarily a normal sequence of commands or sequence of doing things, and it can detect there's some sort of anomalous behavior going on and kind of thwart that threat.
Mhm.
So it's kind of a multi-layered approach. I mean, from personnel to onboard detection to on the ground detection, response capability, physical security. There's all sorts of different things that kind of need to go in there. But I think the key is just the takeaway is don't just assume if an insider is there that does something that its mission's over for you. You really need to kind of build in those security controls around protection against insiders, as
Mhm.
well as the adversaries that, as some adversary from a coffee shop in the Cayman Islands, as they say, protecting from that, protecting from nation states, and protecting from insiders. You need to think about all the different threat vectors to ensure that you're protected accordingly.
Mhm. And so this brings up just another topic, just the vulnerability of satellites and how, they provide sort of an enabling capability in terms of information and communications technology for so many other sectors. So there's a lot of interdependency between, space assets, space systems, and energy grid, financial services sector. Are those other sectors working with, the space enterprise, just to share some of their needs and how reliable they are on space, and maybe sharing some lessons learned about how they're better securing their cyber networks? Is that discussion going on?
I think it is now more than I've ever seen it in the past, and that's just uh, you can probably equate that to or talk about that as it relates to the Department of Homeland Security, and they're I guess recognizing that there is that interdependence between the national critical functions that we have across our nation and the world, for that matter, to how space is an enabling technology. I know that was talked about at the Value of Space Summit in November 2020, which there's plenty of information on the aerospace.org website about that. Just go look that up. But it's I think it's being recognized as, wow, space is a really enabling technology and capability for so many other things that are critical to this country, from GPS. I mean, everyone has handheld GPS in their phones these days. And what type of resiliency is needed for GPS? That's the one that a lot of people talk about. That's with what was just put out, I think with SPD7, just talking about how important GPS is, and that we need to do something about securing that. So it's extremely important to understand the interrelation and value what space technology has, and how all these things play together. It's hard to really correlate. I think there was maybe a correlation you could draw to how the Department of Homeland Security was trying to tackle the problem with critical infrastructure, with all the different industrial control systems, cybersecurity issues that have come up over the last 15 years as it relates to critical infrastructure, to power, water, and those type of things, and how to better secure those environments. It seems like DHS is leveraging some of those lessons learned and things they did to help wrestle that problem and figure out how to do the same thing for space. So they've actually got a point man at DHS now that's working these issues, whereas 5 years ago that wasn't necessarily the case. So it's good to see, and you're seeing things with like SPD5, SPD7, and other space policy directives being put out that's really shining a spotlight on, like, hey, space is super critical. They don't always tie all those things together, but people that kind of work in this area know that how space is really critical to helping all these other sectors. It's not just a intelligence community asset to do something these days. It's an asset for the way of life that we currently operate in America and worldwide. We operate and expect space to be there and work for us, space technology, and it's kind of just ignored and expected to be there, and we really need to get this the security problem under wraps as much as possible, because we have such a high dependence on it.
Yeah, we know that DHS, one of their major stakeholders is commercial industry across those 16 critical infrastructure sectors, and so with the commercialization of space, I think that sort of prompted their interest in better understanding the space sector. And so, and we know that they also had some authorities originally to support establishment of information sharing and analysis centers. And so within the last year, the space sector has stood up its own Space ISAC, and Homeland Security has been very involved in enabling and supporting that. So that's been a great thing, and Aerospace does participate as a founding member in the Space ISAC. So they're doing some great things. There's a SPD5, Space Policy Directive 5, Space Cyber Task Force that you and I are part of. There's also, you mentioned the Value of Space Summit that we co-hosted with them last year. We're going to have a VOS 2 in 2021. That's exciting. So there's just a range of very different things. One other initiative we're working on with Space ISAC is the Lock Shields exercise, which is a NATO exercise. And I guess, Estonia, I think it was 2007, was attacked by Russia because Estonia, I don't know, something happened with one of their statues or something. So they launched the cyber attack on Estonian government, and the government said, how do we handle this? Do we just keep it close hold, or do we share it with the world and try to get help? And so that sort of, they chose to go, open it up, and now they're one of the leading, nation states focusing on cyber. So the Lock Shields is part of that. So that's been a great way. And Lock Shields, NATO invited Space ISAC to be a part of the exercise that's coming up this spring. And they're going to it's the first time the space sector has been involved, and also financial services, I think. So we've developed some injects for that exercise. It'll be interesting to see just all these different things, that are involving space, because I think people, as we said, are realizing that it's such an enabler to all of their critical infrastructure sectors. And so just pushing that a little bit more on in terms of maybe moving over to some policies. You've mentioned some SPD5, which is the Space Cyber Executive Order that came out last year. So can you just describe, what is that, and what does it include? What more is needed there? And how is Aerospace specifically helping to push that forward?
Kind of could be boiled down into one sentence or two sentences if you really want to do it. So it says we must secure the ground and space segment during all phases of development using a risk-based full lifecycle cybersecurity. Which, if that's your main takeaway, then that says basically pretty generic, right? But it does go into a little more detail. But it's all about what security can you afford given your mission context, given your design is, and how much risk are you willing to accept is kind of what they're getting at. But they do go into some details on it and some things that you really need to focus on. So it has a couple of interesting call outs related to operational technology or industrial control system for the ground system, as well as the importance of software and how it needs to be secured for ground and space. And then more specifically, it kind of dives into protection of some of the things that most people who work in this area are thinking, well, obviously you would need to do this, but it's good to get it out in a policy directive so that we're kind of all reading from the same sheet of music. Is physical protection, physical security of the command link, so the TT&C environment. We need to protect physically. We need to protect the TT&C environment using encryption authentication, which is pretty obvious, as well as consider jamming and spoofing protections. So those are kind of the things that everyone would expect to be in something like SPD5. And then it talks a little bit about the importance of doing supply chain risk management and insider threat protection, as well as adhering to kind of basic cyber hygiene as from the NIST guidance from the cybersecurity framework and risk management framework. So when you talk about SPD5 and kind of those bullet points, it really, people that have been doing this for a long time, especially like in the national security sector, are like, yeah, obviously we've been doing that for 20 or longer, 20 years or longer. We need to protect TT&C. We need to do encryption. We need to do authentication. We need to protect against jamming, spoofing. So it's kind of well known that those are the case. But it does call out some things that are kind of applicable and a deficiency across kind of all sectors, which is the supply chain risk management problem that we've seen, as well as insider threat is in protection, which we've talked a little bit about already. So it's kind of mixed signals on what people think about SPD5 depending on where your background is. But one of the things I do recognize and hear people talk in the civil space community was the security guys who work in civil space have kind of been pushing uphill for a while, saying how, well, the threats have changed. We need to do things differently than we've always done them. We need to ensure we have these protections in place. And, when you have people in the civil space community who've worked there for years and decades, they're all about why to change anything, why change what's working type of thing. So you kind of have that uphill battle. But then when these policy directives come out from the highest levels of the federal government, that really provides some ammunition for these guys to say, hey, no, we have directives and guidance from the top of the federal government that we need to be doing this. So that's good. But where SPD5 is I don't want to say deficient, but really lacks some specificity is in how to do some of these things and how to do proper supply chain risk management for space ground systems or space vehicle, or how to do proper insider threat mitigation and what that means. So that's where SPD5 and the ISAC community can really come together. So, there are individuals, SMEs, and groups that have been doing these things and putting out guidance and working in this area to secure space for a while. And so they've got best practices. They've got probably requirements and policies of various places. That's good to see. So I say that's the next step is now we have this high level policy document that kind of supports some of the ideology that we've been talking about for years about the importance of securing the space systems. And now we just kind of get to work on what does that mean and translate it down to things that are actually implementable and get the word out to the various communities about it.
Yeah, skipping ahead more recently, SPD7, which is the PNT Resilience Space Policy Directive, just came out mid January, so it's hot off the press, and that references PNT cyber, GPS cyber. And it's interesting because SPD7 is really reinforcing an executive order that came out last year, 13905, which had a similar title, PNT, reliable PNT. So anyway, how do you see SPD7? How do you see us working cyber security and GPS going forward? Or what can we take away really? And are there any next steps or actions that industry should take?
Well, from SPD7 perspective, maybe I could abstract it up a level. So the importance of SPD7 is they've recognized at least one component of the space system enterprise as being super critical to our nation's capabilities, being GPS. So GPS is obviously a huge asset for America and the world, because we use it for literally everything. Everybody has their own handheld GPS. We use it for distribution of all sorts of critical resources across the country. So GPS is super critical. So they basically want to put out a directive, not just SPD5 says do cybersecurity for space in general, but SPD7 is really saying, hey, we need to ensure we have resilient and we have secure GPS implementation as well. So that's kind of the takeaway. Is I could foresee potentially if there are other space-based capabilities similar to GPS that is critical to the country, other directives coming out and similarly stating, hey, we need to do these are important and we need to make sure they're secure. That's kind of the takeaway I have from SPD7 from the cyber perspective. Is we've identified GPS as a critical function of this country, and we need to ensure its resiliency and capability as well. From the cyber perspective, obviously is included in that. So that's kind of the takeaway there. And I can foresee other things happening with other capabilities in the future.
So we mentioned CCSDS a bit. How do you see SPD5 in addition to SPD7 in addition to SPD5 sort of playing out in terms of best practices and international standards? GPS is a US-based asset, but it's appreciated and leveraged and used around the world. So is that something that the international standards community might think through or focus on at some point?
Yeah, so there's really not at least to my knowledge, and kind of an international standards group outside of what kind of exists with CCSDS, which is the Consultative Committee for Space Data Systems. So that's a group of mainly civilian space agencies get together and work on space standards and things like that. Not just security, just kind of space standards in general. So I don't see necessarily CCSDS specifically working on the GPS problem per se, but they do work on various problems as it relates to securing just space in general. So it's the security working group being the one I'm most familiar with because I've worked in it for a few years, is kind of a grouping of all the other quote unquote NASA's across the world. So all the other countries, NASA's, CNES, ESA, DLR, things like that. Those agencies come together and work on these security problems, and kind of bring some of the best practices from each agency and standardize on them and put it out via publication. So that's a good, from an SPD5 perspective, there's probably some interrelation from CCSDS, maybe SPD5 calls for the communication of best practices. There's quite possibly, I would say there is several best practices and standards written by the CCSDS group that could be kind of promoted through SPD5, as a conduit through the ISAC to get that word out. So I kind of see some interrelation between ISACs, trying to build out the SPD5 implementation plan, looking for standardization and standards bodies and people who have kind of worked this problem in the past and trying to communicate that out. So I think there's definitely some interrelation there between what CCSDS is doing from a standards perspective, as well as what ISAC and SPD5 are looking to get out there.
Good. Just moving on to another topic, not policy related, but what are some of the conferences, workshops, exercises that you and other aerospace colleagues like to participate in, and what have been some lessons learned and next steps that have been revealed?
Yeah, so in general, there's a lot of really great cybersecurity conferences that are out there, just in general, learning cybersecurity. There are a few niche ones that are popping up, or I guess components of big ones that are taking more of a focus on aerospace and space cyber type of problems. So the traditional DEF CON and Black Hat are obviously big ones, and more specifically DEF CON, in that over the past 3 or 4 years, more so this past year than previous years. There was a, aerospace, used to be called an aeronautics village, but now it's an aerospace village, which ISAC actually I could help sponsor and work with, I think some. So DEF CON being one, and I foresee DEF CON being maybe a leading candidate for space cyber conferences, being that they have that dedicated village where you're going to have all sorts of security presentations really focused on aerospace and space systems, which you don't typically get in a lot of other conferences. Like Black Hat, for instance, doesn't have a track or a focus on space systems, where DEF CON does now have the aerospace village. And with that, within the aerospace village, last year they had the event Hackasat, which was, you can go to hackasat.com and look up what that was, but essentially it was a competition from teams across the world trying to hack into or recover a satellite technology that was kind of taken over by quote unquote hackers. They were trying to recover their satellite using hacking means. So it was interesting. So I think DEF CON will be a big one moving forward. I saw some interesting movement with Ascend 2020 from AIAA this year, where there was a big track and focus on cybersecurity. So that one. So what I'm seeing is you're starting to see traditional aeronautics and aerospace type of conferences pop up, and then they're starting to really get into some of those dedicated tracks specifically to security. So that's really good to see. So, but there's not a space cyber conference, if you will. The closest thing I would imagine is the DEF CON and what they're doing with the aerospace village. So from a lessons learned perspective, it's just been great just seeing this the security research community starting to take an interest in space cyber as a technology and a research area. So I foresee, in the next 5 years, that being a really booming area for researchers to get into, which is the activation energy and barrier to entry to do that space cyber research was super high 10 years ago, but now there's open source technology, open source simulators, and all sorts of things that are available that people can kind of do on their own and get accustomed to it and start their own research. So that's good. I actually did a talk at DEF CON this year talking about how to exploit certain parts of a spacecraft using command link intrusion and various things. So it's on YouTube. If anyone's interested, you can just go to the Aerospace Village YouTube feed and see it.
That's awesome. Thanks, Brandon. So we always would love for policy to get ahead of technology. So when you're thinking about future technologies, what's there that the policymakers need to understand sort of right now that's coming in the future, that they might need to start thinking about, how do we better approach or think through policy alternatives for either areas where technology might prove to be a risk for infrastructure, space critical infrastructure, or where it's just advancing space critical infrastructure.
Yeah, so I guess I would, and we saw it with SPD5, but I would like to see the expansion from the traditional thinking of ComSec, communication security, and transmission security. Transec are the end all be all and only security we need for systems. And we've talked about other threats from insider to supply chain and various things. So having policy, this isn't really a technology question or answer per se, but it's more of change the thinking outside of the traditional, hey, we only need to worry about authentication and encryption type of things on the command link, and extend past that. So, we need to extend policy outside of just those two areas and focus on building the fits in depth approach so that we can be more resilient and we can recover, but to space cyber attacks. But what I would say from a technology standpoint is there has been a lot of work, obviously, in artificial intelligence, machine learning type of things, and that technology does lend itself pretty well to solving some of the onboard analytics and onboard command or onboard cyber protection capabilities on board spacecraft. So not every spacecraft has robust capability on board to do some sort of automated detection, response, and recovery capabilities. And some of the AI ML things that have come to fruition in the last few years, I think could aid in that. Because if you think about the space cyber problem and the attacks and your traditional IT-based defenses, if you think about how we've done IT-based defenses in the past, a lot of it is signature-based. And if you think about malware on a spacecraft, that's not going to have necessarily a signature for it. So it's going to have to be behavioral analytics type things and machine learning to understand, hey, what is my baseline? What does normal look like to me, and how do I detect abnormalities? Which would cover supply chain intrusion or any other type of intrusion. So that's kind of where I think I'd like to see policymakers kind of shift their thinking of the minimalist approach of let's just worry about encryption. And that's the key thing that we have to worry about. Although that is extremely important and probably the number one thing to worry about. But I think we need to also extend beyond just that minimalist ideology and say, okay, we need to build in protections elsewhere. And that's what SPD5 was trying to communicate, I think, is you can't just do the one thing and worry about, you got other things to worry about. And I'd like policies across agencies to reflect that accordingly and get implemented in requirements.
Yeah, you sort of need that policy lever of sorts. And it also goes back to, it just aligns with your defense in depth approach. It's not just one single thing, but a layered, multiple approaches. So we've had a ton of conversation, not just in this hour, but over months and months and months, years, about all this stuff. But one thing is, I don't know if we've talked about this. You talked about the what needs to happen in terms of, how do we think, what are those key technology pieces that policymakers need to better understand how to, legislate around, or but who needs to also be involved in the conversation? Are there any groups that, and we kind of talked a little bit about, space needs to make sure that they're talking with, their energy sector and the financial services sector, because there are those interdependencies. We talked about standards organizations. Are there any communities of interest that we haven't included in the conversation about space cyber that might be able to weigh in and have some impact or thoughtful response?
Well, so I think there personally are a lot of different people or groups of people having conversations, but I don't think there's a lot of those groups talking to each other. So if that makes any sense. So you have maybe the National Security Council having their information and meetings or whatever. You have the White House doing what they do, or NIST talking, or DHS, or CCSDS, or varying agencies doing things. So there's a lot of silos that are kind of trying to solve the same problem, it seems, but there's not a good horizontal integration of a lot of the discussion at this point. And I think who needs to be involved in the conversation, I think it varies on the problem you're trying to solve. I think one thing I'd like to see is be more granular with the problem you're trying to solve, and not say, well, we need to do cyber security for space. Okay, yeah, we all agree on that, but like let's define an objective and let's figure out what we're trying to achieve, and then let's go after that one thing. And then you can say, if we're trying to establish this one objective, then who are the parties that need to be involved and have a conversation? Because what I see is just kind of bland data calls go out to varying SMEs and various groups, and then it kind of gets aggregated and then communicated in various ways. And there's bits and pieces of information that get kind of spread out across, but I don't see a lot of that talking across various people communities. So and just this is kind of a problem not just in space cyber, but the policy. We've talked a lot about policy. So what you see sometimes, I'm not saying it happens all the time, but is the policy people don't always talk to the technology people, and then you automatically have a rub, and you can't really, you're at an impasse. As soon as the policy comes out, is like, where did you even consider X, Y, and Z in this conversation? Because we can't do that. For instance, like a simple one, very rudimentary simple one would be like, okay, all small sats must have type 1 encryption on it, which is not really a real requirement, but say that someone levied that requirement for policy, not really thinking about, well, there's that means you have to have hardware-based cryptography or something like that, which you can't do with swap concerns and things like that. So there's varying policy level things that occur, and those conversations have at higher levels, and they don't always factor in some of the lower level thinking. So that's where I see getting that conversation really going, and that's why I like doing things like this talk, and as well as communicating
Yeah.
in various forums is important. To you never know, if you have one person in the room that you can have an effect on, then that can spread out to multiple people. So it's what's important to have all these dialogues, and that's something, just closing out this piece of the conversation is the fact that there are more people talking about this problem than ever before, uh, which proves that we're moving in the right direction. But we're a long way from being, problem solved in that regard. So it's good to see a lot of conversations going on, a lot of presentations, a lot of conferences talking about this problem now.
Yeah, I mean, I think, when you think about technology talking to policy, we're so fortunate. We sit in a 4,000 team federally funded research and development center where everyone focuses technology R&D, and that we also have a Center for Space Policy and Strategy that can directly talk to the technologists, the scientists, and that conversation is occurring. So really lucky. Great to talk with you, Brandon. Really appreciate it. Always fun. So thanks everybody for joining us, and please join us on the channel. And if you have any questions, please do reach out. Thanks so much.
A big thanks to Brandon and Lori for a great discussion on a very timely topic. And thank you to our production team, James Liggins and Sarah Pannoni, located in the Los Angeles area. As always, check us out on Twitter using hashtag the Space Policy Show, and sign up for our news alerts at aerospace.org/policy. Tune in next week for an episode on rethinking capability development for the space enterprise with Aaron Ryan and Allie Taylor as they discuss the novel concept of designing for principles.